Hello again. So, now that we have learned a little bit more about cylinder, or a little bit about cylinders in general, let's solve a problem, a practical problem. So, the figure on the right shows a cylinder with a radius of 3 and a height of 5. So, that means this length on here is 5 up and down, and the radius going from the center to one of the outside points has a length of 3. And I'll just label this point O. Find the volume of the cylinder. So, if we can kind of imagine a cylinder as a prism with a circular base, then we can apply the same logic. So, we would take the area of the base times the height. Well, what's the area of the base? Well, that would be pi. Since it's a circular base, it would be pi times the radius squared. So 3 squared. Then multiply that with the height of 5. 3 squared is 9, times 5 is 45. And we're just going to keep the pi as a part of our answer. And that gets us the volume. Same process as a prism. Base time area of the base times the height. Now, part B. What is the lateral surface area of our cylinder? Well, we don't know really how to handle a curvature like on the edge. Remember, the lateral area is the surface area without the two bases. The easy part's finding the area of the two bases, but in our case we want to find everything except that. Now imagine if you had a cylinder in your hands like a Pringles can, and you were to take a pair of scissors and cut down the Pringles can along the side and remove the bottom and then split it open. What kind of shape would you get? Well, if we unraveled this cylinder, it would make a rectangular shape. So we can represent that by drawing a rectangle. It can be a little hard to imagine, but just try to, again, imagine that cutting the Pringles can down the middle and unwrapping it. This would be the side of the prism being unraveled, where we would know that this distance here, the length would be 5, because that would represent the height along which we would unravel it. But what is this top part? Well, the top part would correspond to the circumference of the circle, because the top portion of the rectangle, let's say if we were to cut it down this line itself, unwrap it, this point, it would be one end here and then one end there, like one end here and one end there of the circle, unraveling it, making the entire circumference of the circle. So, how can we represent that circumference? Well, that would be 2 times pi times the radius of 3, which is equal to 6 pi. Therefore, we just have to find the area of a rectangle now. So the lateral area is the length times width, so 5 times 6 pi, which gives us 30 pi. So that is part B. Part C, what is the total surface area? Well, that's easy. It's the lateral area. So 30 pi plus the area of the two bases, the two circles. So the area of each circle is this pi times r squared, or pi times 3 squared, or 9 pi. That's the area of one circle, but we have two bases, so two circles, multiply that by 2. So we have 30 pi plus 18 pi, which can be further simplified into 48 pi. And that is part C. Now, part D is asking us to find formulas, general formulas for the volume, lateral surface area, and total surface area of a cylinder with a radius and height of r and h respectively. So, let's get rid of some of this, but we can keep the same diagrams because they're going to provide us with good logic. So this is the radius, and this is our height. We know that when we unraveled this, the lateral area, we got a rectangle that had the height and the circumference as the top part, so 2 pi r. And now let's go and start looking at our formula. So what's volume? Well, the area of the base times the height. The area of a circle is pi r squared times the height. So that's our formula for volume. Lateral area is going to be, well, it's this rectangular area down here, so that would be 2 pi r times the height, so 2 pi rh. So then the surface area is equal to the lateral area, 2 pi rh plus 2 times the area of the circle, which is pi r squared. And we can manipulate this equation a little bit more by factoring. So surface area is equal to, well, what are the common factors? 2 pi and r are in both terms, so 2 pi r, and what do we have left over? Well, we have an h plus an r. So sometimes you'll see it written both ways, but here are the 3 formulas, which we'll see here. So volume 2 is pi r squared times h, lateral surface area 2 pi r times h, total surface area 2 pi r h plus 2 pi r squared. Don't need to memorize these formulas because if you understand how we got them, they're pretty intuitive. And when we deal with cylinders or curved surfaces, unrolling the curved surface into a rectangular shape or some sort of other shape tends to be a very good strategy to solve these types of problems.